Okay, today what we're going to be looking at is we're going to be looking at factoring polynomials. We'll be looking at factoring polynomials today, which is pretty easy. We talked about polynomials last class, or last video. The I can statement, the learning target today, your learning target today, your learning target is I can factor polynomials. I can factor polynomials. Okay, so the first thing I want to talk about before we talk about factoring polynomials is greatest common factor. Hopefully you know what the greatest common, the GCF, that is the greatest common factor. What is the greatest common factor? The greatest common factor is, what is it? How would you define the greatest common factor? It would be I guess you could say it's the biggest number or letter or power all the terms have in common. Okay, so let's say like if we had a polynomial like 24, let's say we had 24y to the fourth minus 54y to the third. Looking at that, what do they have in common? What's the biggest thing that they have in common? Well, I can see that they have a y. So the numbers, you can see the 24 and the 54. What's the biggest number that they can have in common? I think it's 6, right? So I'll put 6 right here. And then look at your y's. This is y to the, what's the least or the highest power that they both have. So this is y to the fourth, this is y to the third. So I believe the greatest common factor is y to the third. So then you just have to think and work backwards, like, okay, 6y to the third, and then I'm going to say, well, what number times 6 will get me 24? Well, that's 4. And y to the third, using the rule, y to the 1 is going to get that. And then 6y to the third times what will get me negative 54? Well, that's minus 9. That's the greatest common factor. That is probably something that should be reviewed for you guys because you had it back in Algebra 2. So let's talk about what we're talking about today. So there's a couple things. There's the difference of squares. The difference of squares. So when you say squares, you're thinking something squared, and difference means minus. Something squared. That's the difference of two squares. Now you have to know your difference of two squares. Do you know your perfect squares? You know, when I say perfect squares, it's like 1, 4, 9, 16, 25. What's the other ones? 36, 49, 64, 81, 100, what is that? 121, 144, dot, dot, dot. The more you know, the faster it is. But the difference of two squares, when you factor it, it's just a shortcut. But what happens is it's always going to be the box plus the other box and the box minus the other box. What do you mean by that? Because they gotta be perfect square roots. So here's like an example. Like if I have 36 w squared minus 25. Have you recognized, do you recognize, or like, this is a perfect square and this is a perfect square? Well, what's the square root of 36w squared? Well, that's 6. That's going to be 6w. And what's that? That's 5. So this becomes 6w plus 5, 6w minus 5. And that's how you find the difference of squares. It can get a little crazy if there's fractions or whatnot, but it's okay. You've seen that one before, probably. Difference of squares. All right. Then there's a couple other ones. There's the sum of cubes. Sum of cubes. So what does this mean? You have, we'll say it's a box cubed, and you're adding another box that is cubed. There's that one, and then there's also the difference. There's also the difference of cubes. There's also the difference of cubes. And guess what? That's a box right there. Now, what helps is knowing, so you know your squares real good, but you need to know your perfect cubes. So how you do that? 1 cubed is 1. 2 cubed is 8. That's the perfect cube. The other ones, I don't know them all. It's 27, and 4 cubed is 64. And then my other one is 125. That one comes up a lot. That's 5, I think. 6 is 216. And then 7 is 343, dot, dot, dot. I don't really know too many after that, but that's how it works. So the sum of cubes and the difference of cubes. How does this come out to play? It might help if I show you this. So if we just did like um, x cubed plus y cubed. How does that come? That will factor out to this. You take the cube root of x and the cube root of y, so that's x and y, and then it's plus, right? And then if you remember back in class, where I'd say square the first, square the last, you square the first term, that's x squared. You square the last term, that's y squared. In this case, it's going to be plus. And then you multiply the two together, which would be xy. You don't double, and it's going to be the opposite of the sign. So there's that. That's the factorization of the sum of cubes. Difference looks pretty similar. The difference, check this out. It's the same thing. You still take the cube root, but you're going to put a minus here. You're still going to square the first term. That's correct. And you're still going to square the last term. That's correct. And everything, multiply the two terms together, and you have that. That's how it works. That's the sum and difference of cubes, if that makes sense. I'll give you an example of one of each real quick. So check it out. Here we go. Here's an example of one. The first one, I got h cubed plus 125. Okay. So first question I ask is this a sum? Are they perfect cubes? I think h cubed is a perfect cube root of h, and 125 I know from I think that's 5. So what does this become? This, if I follow my rule, h through 5, and I think this is going to be the plus right here. And then I square the first term, which is h squared. I square the last term, which is 25. I multiply the two, 5h, and I do, I think, a minus there. So minus 5h. So it comes up like that. You want to see the difference of cubes? The difference of cubes, you can do something like, here's x cubed minus 243. Do you recognize that those are two perfect cube roots and there's a difference? Well, then you just do this. You do x here. And what's the cube root of 240? I'm sorry, it's not supposed to be 243. It's supposed to be 343. What's the cube root of that? I think that's 7. And we're going to do a minus here. And then you do the same thing. You square the first term. You square the last term. You multiply the two, which is 7x. And then you keep the sign positive. And there's that. So again, that's just something that you normally have seen a boatload of times, okay? So now the next thing I'm going to talk about is factoring trinomials, all right? So I'm going to show you x factor, and I'm going to show you factoring by grouping. Okay, so I'm going to show you x factor and factoring by grouping. So we're going to factor trinomials. So how do you factor trinomials? Well, the first thing you do, step one, draw the x. Step two, multiply a times c. Step three, find b. Step four, list factors of AC. Find factors that add up to B, right? And then that's 5. Let's see, step 6. Draw a rectangle. Step 7. Lead term and last term in corners. And step 8. Factors and open boxes. That makes sense. And step 9, tick, tack, toe. All right, so there is your how to factor trinomials. All right, so step 1, draw the x, multiply a times c, find b, list the factors of a times c, find the factors that add up to b, draw the rectangle, lead term and last term in corners, factors in open boxes, and then tic-tac-toe. So let me just show you how this works. Okay, so here we go. I'm going to lay that out as if, so I'm going to go ahead and factor, I'm going to do one like, I don't know, let's just see if we do like how about 2d squared minus 13d minus 7. All right, step 1 says draw the x. So let's draw the x. Multiply a times c. A times c, I believe, is negative 14. Find b. B is negative 13, right? Then it says list your factors. List your factors. Step 3 says list your factors of a times c. So 1 and negative 14, 2 and negative 7, 7 and negative 2, 14 and negative 1. So we list those factors. Now we got to find the factors that when you add them up, you get b. So when we add them together and you get negative 13, which one is it? It would be this one right here. So I'm going to put those guys here, 1 and negative 14 right there, right? So we find those. Step 6, draw the rectangle. So draw the rectangle. Draw the rectangle, right? Lead and last terms in corners. So what do I mean by that? I'm put the lead 2d squared and negative 7 in the corners. And then it says factors in open boxes. I'm going to put a 1d here. I'm going to put a negative 14d here. And then number 9 says tic-tac-toe. So look here. What do these guys have in common? 2d squared negative 14d is 2d. Well, these guys have in common nothing. So we're just going to say plus 1. Up and down here, we're going to say it's just d. Up and down here is negative 7. So then this factors out to d minus 7 times 2d plus 1. That's how that comes out to be, right? d minus 7 times 2d plus 1. Make sense? Okay, I'm going to show you how to do factor by grouping. It's pretty much the exact same thing, only you don't draw the rectangle. Okay, so if I'm going to say factor by grouping, well, let's just do one. Let's do one real quick. If you say factor by grouping, it helps when you have, like, if it comes up in the situation. So you could do factor by grouping with trinomials, right? But I'm going to show you like one where, like, if I gave it to you like this is interesting. You won't see this too often, but it might be. So here's one. So here's 6r cubed, right? Minus 9r squared plus 10r minus 15. I can't factor because it's not a trinomial, but there's 4 of these guys. So what am I going to do? First thing I'm going to do is I'm going to group them. So step 1, group with parentheses, right? So there's step 1. So group with parentheses. 6r cubed minus 9r squared. I'm going to group that in this parentheses plus 10r minus 15, right? And then number 2, find GCD. Factor out. All right, so what's the GCD here? On the first one, 6r cubed and negative 9r squared. I believe that might be a 3r squared, right? And then what's this guy? I believe that guy might be a 5. Now I'm going to find GCD, and step 3 is factor out. So when we factor it out, we get 3r squared, and this would be 2r minus 3 plus 5, and then this should be the same thing.
Memorial, please call 5001. T, please call 5001.
What should happen is this and this should be the same, right? So 4, factor out binomial. So if I factor out the binomial, I have 2r minus 3. What's left? 3r squared plus 5. And you are done. And that's how you factor. That's more the advanced factoring type thing. So hopefully that makes sense. I'll see you in class tomorrow, and may the force be with you.